So let's talk about commutator algebra. So consider two operators A and B. The commutator of two operator is given as A comma B in square bracket as AB minus BA with caps, and anti-commutator of two operator is given as in curly brackets AB plus BA. Two operators A and B are said to commute if A cap B cap is equal to B cap A cap. That is, commutator of AB is equal to 0. Another thing to note is that any operator commutes with itself. That is, if you take the commutator of A cap with itself, it will obviously give you 0. This implies that any operators commutes with itself. If two operators are Hermitian and the product is also Hermitian, these operators commute. As you can see from the first equation and the second equation, we can easily prove that AB equal to BA, which implies that commutator of AB is equal to 0, and hence these two operators commute. So let's see some properties of commutators. First is the antisymmetry property. The commutator of AB is the negative of commutator of BA. Second one is linearity. That is, if A is commutated with B plus C plus D operators, then A will linearly commute with B, then C and D. Third, we see the Hermitian conjugate of a commutator. That is, commutator of A comma B dagger is equal to B dagger A dagger commutator. Fourth, we see the distributive property. That is, A comma BC is equal to B AC plus ABC. Or if AB is commutated with C, then A commutator BC plus AC commutator B. Another thing that commutator satisfy is this Jacobian identity, which is given by this expression. Also, all operators commute with scalars. That is, if A is our operator and B is a scalar, then A will always commute with any scalar. So let's say an example of commutator of position and momentum operator, which is given by IH cross. So let's try to prove this with the help of a function psi. So as we know, two operators, the commutation is given by, can be written as xpx minus pxx multiplied with psi. So let's see. As we know, our position operator can be written in one dimension with the x coordinate, and our momentum operator in one dimension can be written with negative of IH cross dou by dou x. So let's try to put these things in this equation. So this becomes x into minus IH cross dou by dou x plus IH cross dou by dou x x multiplied with psi. So this thing becomes, let's take psi inside, minus x I h cross dou by dou x psi plus I h cross dou by dou x x psi. So using the UV rule, we get minus x I h cross dou phi by dou x plus I h cross dou x into dou phi by dou x plus phi into dou x by dou x. So this thing cancel out and becomes 1. We get minus x I h cross dou phi by dou x plus I h cross x into dou phi by dou x plus I h cross phi. As we can see, this thing also gets cancelled, and finally we get x cap px cap psi as I h cross psi. So if you remove psi, we can arrive at this equation.